Hey everybody, go ahead and take out your math journal. Today is September 29th, 2020. Go ahead and write today's I can statement. Pause the video, write the I can statement, and then unpause and come back and join me. So welcome back. Today's I can statement. I can connect a visual model to the standard algorithm for multiplying multi-digit numbers without renaming. Do we understand all of these words in our I can statement? The visual models that we're going to use today are our tape diagram, and we know how to draw a tape diagram from 3rd and 4th grade. We're also going to use our area model for today, which I know you learned at least last year. So we're going to connect that visual model to the standard algorithm for 5th grade, which I think you are going to love. So standard algorithm, as we've been learning, a set of steps that help us solve math equations. We know what multiplication is, multi-digit numbers, numbers with more than one digit, without renaming. So there's no bundling that's going to be involved today. Okay, no carrying, no bundling, and moving from one place to another. So let's get started. The first problem we want to take a look at, and we're not going to write this in our journal, I just want you to watch. So I have my whiteboard here. I'm going to zoom out a little bit. And I'm going to write 21 times 5. Now you may be thinking, Miss Mullinex, I already know how to solve that. But we want to make some really good, strong connections today between our visual models and our standard algorithm. So really stay focused for me. So the first thing I want to do is show 21 times 5 in a tape diagram. So this may look a little different from last year, or it may look very similar. But what I want to do is make each unit be worth 5. And how many 5s? How many copies of 5 do I want? I want 21 of them. 21 5s. So instead of making this tape super long, I can put these 3 dots, which means to continue in the same way. Okay, so 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5. Okay, 21 more times. And then at the end, I will put another 5. Okay, so all together, our whole piece of tape, we have 21 5s. I hope that makes super good sense. So what we want to do today is connect this to our area model, okay? So we're going to take our tape diagram and kind of like that number line when we were rounding, we took that horizontal number line and we went and we turned it and made that vertical number line. Right now, we are going to sort of turn that piece of tape vertically, and we can kind of show there's our 5, 5, 5, dot, 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 5. And we know that we want 21 5s. So all we have done, guys, oh, there's a little bit of a glare. I'm sorry about that. So we have just taken our tape diagram and we have turned it just like this so that it is vertical. So the next thing I want to show you is how we can take this tape diagram. I'm looking for my tissue so that I can erase. Please hold. Coming back. Okay. I want to erase the inside of this because I want to show you the coolest thing ever. Okay. I'm going to take away the inside for a second. And I'm going to turn this tape diagram into an area model. Ooh, yes, she is. And this is how I'm going to do it. 21, I'm going to put at the top of my area model. And I'm going to put, no, I'm not, negative. Nope. Let's put 5 at the top. And now I'm going to decompose the number 21. That's 1 1 and 2 10s, which is 20. So I've decomposed the number 21. Now, what I need to do in my area model, I'm not going to do this yet because here is the super cool part. I'm going to connect this area model to a standard algorithm over here on the right. Standard algorithm. Okay. Folks, just like when we were multiplying decimals, we need the number with the most digits to be on the top for our standard algorithm. So the number with the most digits, the factor with the most digits, is 21. So 21 goes on the top, and 5 goes on the bottom in the ones place. So there is my problem. Here is my area model. Here is my standard algorithm. Watch this and just be amazed. 5 times 1, or could I also say 1 times 5? Yeah. Why is that? Because of the commutative property of multiplication. I can multiply those two factors in any order and get the same product. So 1 times 5 is 5. Watch this. 5 times 1 is 5. And then 20 times 5. Ooh, do you remember when we were multiplying multiplying basic facts and multiples of 10? So I could say 2 times 5 is 10, but then I'm also multiplying it by 10 again. So that adds another 0. Okay, 20 times 5 is 100. 100. What is 5 and 100? 100 plus 5. Take a look at that. 105. How cool is that? It's the coolest thing ever. Just wait till you see the next video.